All right, folks, here we go. It is time. All right, so here's our exam from last time. $3,000 is loan. So that's our principal for 4 months. So our time is what? If it's 4 months, it's what, 1/3 of a year? So T is 1/3. At this annual rate, so our R here is 0.045. How much interest is earned? Well, you know that I party, right? So if P is 3,000 and R is 0.045 and T is 1/3, plug that into our calculator. What is this? 3,000 times 0.045 divided by 3, we get 45 bucks. Exactly, $45. All right, if we paid $120 to a loan company for the use of $2,000 for 90 days, what's the annual rate of interest? So they're looking for R, okay? So let's see, our T here, 90 days, that's what, a fourth of a year, 99, yeah. So T is 0.25. I mean, we have what? I, a P, an R, and a T. There's 4 letters here, right? And we also have the amount coming into play, right? So let's see. You borrowed $2,000 and then you had to pay back 2,120, right? So let's see, what did they charge you? Well, the principal was 2,000 bucks and the amount would be $2,120. Does that make sense? So what we have here is the amount is principal plus interest, but the interest is PRT, right? So if the amount is PRT, we're trying to solve for R, right? So if we subtract P from both sides and then divide both sides by PT, we have R is A minus P over PT. That's our rate. All right. And again, this is just simple interest, right? We're not getting into anything difficult yet. So the amount was 2,120. The principal is 2,000. Notice these are both in dollars. And the bottom we have dollars again times time, 0.25. So we plug this into our calculator. We have what, 120 divided by 2,000 divided by 0.25. We get 0.24 exactly, which is exactly 24%. If you're getting anything other than exactly 24%, you're doing something wrong. So this one's fairly simple. It's simple interest, and the word problem simple. It's pretty straightforward. Now, just before we do the quiz, I'm going to give you some equations I've already told y'all, right? Compound interest. A equals P times 1 plus R over N to the NT. All right. All the letters mean the same thing, but here N is the number of times interest is collected in a year. Okay. So if it's compounded monthly, then N is 12. If it's compounded daily, then N is 365. And this should make sense because R is your annual interest rate. If you collect interest every month, you would collect 1/12 of the rate. every month instead of the whole yearly interest rate. Doesn't that make sense? And this is how many times you collect interest in a year. So if it's monthly, it's 12 times the number of years, right? 12 times per year. So this is the number of times interest is being collected. This is the interest that you're collecting each time. Then you have continuous compound. What that means is that if you can compound the interest an infinite number of times, meaning you're collecting interest continuously, n goes to infinity, and what you get is all this stuff here, the p stays the same, but all this turns in e to the rt. N disappears. So you're dividing by n, so this gets smaller and smaller, but you're raising it to a higher and higher power. So take a number that's getting small, 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 raise it to a higher, higher power. Eventually it balances out and you just end up with the number e. So these are the two kinds of compounding of interest you can have. In number of times or an infinite number of times. These are your two formulas. So for a quiz here, compounded monthly, you'd know n is 12. Compounded continuously, you know to use the continuous compounding of interest. All right. Amount p e to the rt. This one was amount equals p 1 plus r over n to the nt. All right, so whenever they just give you the numbers and you just plug them in, the hardest part of the math is typing it into your calculator correctly. A lot of people will do this. They'll accidentally multiply by t instead of having that in the exponent because they won't have parentheses there in their calculator. And it depends on the calculator you're using, right? If you're using your iPhone calculator, you kind of have to know what this is ahead of time. But I'll go through the steps through both calculators here. So y'all should be able to do these in 10 minutes. It's basically just, what is the amount? What is the amount? Well, here's the amount. Here's the amount. All you have to do is plug the numbers into your calculator. That's it. There's no algebra. There's no logs. There's nothing other than calculator. All right, so at 5. We also be able to do this in what, 7 minutes? 5:45. We will work these together. Here's another calculator and see if you're doing it right. So here we go for A. Our amount. See, our principal is $5,000. We have 1 plus our interest rate is 5%. Do this compounded monthly, so n is 12. We have 12, and then t is 2 years. All right. So if I'm using my basic calculator here that has very few buttons, all it has is like the x to the y button. All right. I kind of need to know what this number here is first. We know it's 24, right? So if I'm going to use my simple calculator, I start here. I do 0.05, then I divide that by 12, then I add 1 to that. So I have like a really small 1 point something very little, right? This is always 1 point something very little. Now I need to raise that to the power of, so I hit x to the y, and then type in 24, hit equals, I got like 1.1. Now I multiply that by 5,000. And we get, to the nearest cent anyways, $5,524.71. B is 4 years. The same stuff, but T is 4. So I kind of need to know what this is. I know this is what, 48. I need to know that ahead of time. Sometimes that's a big number. If you're using your simple basic calculator, we need to do 0.05, divide by 12, add 1, turn the phone sideways, do to the power of 48, and then times 5,000. And we get 6,104.42 8. All right, if you got something different, you're doing it wrong. All right. So again, anybody can plug the numbers in, but to get the right answer, you need to type it into your calculator correctly. Everybody's using different things, right? What are y'all using? Who's using an iPhone? The basic calculator? All right. Who's using an Android basic calculator? All right. Anybody using any other program you downloaded? What are you using? Desmos calculator. That's a good one. Yeah. Just go to desmos.com. You can type it in. Yeah. Put that up here. You can go to desmos.com. I bet you could just type it into Google as well, right? Yeah, it's good. All right, number 2, since they say compounded continuously, this is the key word. We have to use this formula. So our principal is 8,000. E to the, let's see, our R is 0.07. And then our T is 6 years. So first off, I start with 0.07 and multiply it by 6. And then I turn my phone sideways and I hit E to the X and then multiply by 8,000. And we're getting $12,175.69. All right, so one thing we can do is mindlessly plug these things in and get the answers, but we kind of want to get an intuition for how things are related. Like, what is more important here in this formula? The interest rate or the time? For this formula, which is basically, this turns into this when n is infinity. All right, so they're basically the same thing. They're both compounding interest. So I'm asking, which is more important, the rate or the time here? Why? Because the time is too long. Yeah, the time is in the exponent here, right? It eventually, like either you'll die or it'll stop compounding. Well, the key mathematically is time is in the exponent. Like here, it's not in the exponent, right? So which is bigger, like 2 to the x or x squared? Well, for small x's, this is bigger, right? I'm sorry, not x squared. 2 to the x, right? For small x's, this is bigger, but it's always the exponential. Exponentials grow like this. R is just linear, okay? So in like the short run, R is important, but in the long run, obviously T is important, okay? So that's why even if the interest rates aren't very much, if you have put it in there for long enough time, you can really add up some money. Little bits add up to a lot over time. So instead of getting that, $4 Starbucks every day, you put $4 in at 4%, and look what that adds up to over 20 years, right? We won't get the math to be able to do that in here because ours is more like, here's a lump sum, wait 20 years. So to do it where it's like $4 each day, we'd have to basically do 20, we'd have to do the same formula for each day. Plug it into an Excel sheet. Kinda, we could come up with it with the same math. You'd have to understand how this formula was derived in order to figure out the formula for something like that. It would just be another exponent, right? Like $4, the principal, each day the principal is different, but that's kind of what this is taken into account. The principal at the second month is different than the first because the new principal is the old principal plus the interest for the month, right? So we'll go through this and where'd it go? In this chapter here. I don't know how much detail they're going to get into it, but I guess we'll go through it in detail. we'll break our backs on this section because this is one of the most important things that you need to know in business. Let's go through every example in detail. All right, at the end of a payment period, the interest due is reinvested at the same rate. Then the interest, as well as the original principal, will earn interest during the next payment. Interest paid on interest reinvested is called compound interest. So here's our example. Let's get the rest of it here. So it's, instead of using the formula right off the bat, we're going to do it without the formula. It'll be great fun. We'll go through this through the 3 quarters because this will help you understand why that formula looks the way it does. Okay, so we deposit $1,000 in the bank and we get 8% compounded quarterly. Quarterly means 4 times a year, right? N is 4. How much will the bank owe you at the end of the year? All right, compounding quarterly. At the end of each 3-month period, you get the interest as well as the principal earns interest for the next quarter. So using the simple interest formula, we're going to use this to get the intuition so that we can derive the formula for the compound interest. So for the first quarter, here's our simple interest. We have $1,000 and we have 8%, but it's only for a quarter of a year, and we end up with $1,020, right? So now for the second quarter, this is our new principal, right? Everything's the same. It's for a quarter of a year, 8%, right? So we have to take 8% and divide it by 4, because we're doing it 4 times. And so at the end of the second quarter, we have this much. So this is the new principal for the third quarter, right? So all you're doing is the simple interest over and over and over again. Here we start looking at the pattern. So how does this compare with simple interest? If you just did it one time at the end of the year, you have 1,080. Now, where's the rest of this thing? I'm missing a paragraph. Hold on. Here, here's the end of the fourth quarter. We need that. So we do it again at the end of the fourth quarter. This is our new principal. At the end of the third quarter, we collect our interest, and we now have that. Now, if we just done simple interest for the whole year instead of collecting interest 4 times during the year, we'd only got 10,080. So we got an extra $2.43 on the interest, on the interest, on the interest, on the interest. Okay. So that's cool, right? So let's see. So let's look at what we did and look at a pattern here. You see this 0.02, right? This is the same as this. That never changed, right? It's the same number for each quarter. That is just 1.02. So we just have the same thing going on over and over again. Okay, so you see where that exponent comes from, that nt, 1 plus r over into the nt. That's what this is right here. This is 1 plus 1 over r. I'm sorry, 1 plus r. All right, over n. 1 plus r over n. That's what that is. And you're getting it over and over again. Every time you take the old thing and multiply it. So if you look at it, let's say our amount at time 0 is just our principal at time 0, right? So our amount at time 1 would be our initial principal, right? Plus, it's our principal plus the interest, and the interest is P naught RT, or 1 P naught 1 plus RT. Okay, so the second time around, this is our new principal. So call this P here. I'll just call this P. So the amount after the second time we collect interest, we'd have this as our new principal, right? That's our new principal, and then we have times 1 plus RT, right? Because this is our new principal. Some notation here. Hold on. Make it clear. I'll call that this. All right, so I'll call this P1, right? Where P1 is P naught times 1 plus RT. Okay, so the amount at time 2, whether it's a month or a minute, is the principal from the last minute or the last month plus the interest that you've earned. But P1 here is exactly this. This is our new principal. This would be P naught 1 plus RT and then 1 plus RT again. So the third time you collect interest, it's the principal, right, plus the interest. But our P2 here is now this, the principal at the end of the second time period. All right, so P2 being all this stuff, and then times 1 plus RT again. So you keep doing this. So if you're doing this n times in a year, right, by the time you get to the end of the year, you have your original principal times 1 plus RT to the nth power. You'd have these things multiplied together n times, right? And then if you keep going, T years, each year you do this n times, n times, n times. All right, so this is every year you get n more of these. That's why you end up multiplying that by T, because you do this n times in a year, and then n more times for the second year, and then n more times for the third year. And that's how you end up with this formula, okay? We better catch all their vocabulary in here too. Interest rates are generally quoted as annual nominal rates. The rate per compounding period is found by dividing the annual nominal rate by the number of compounding periods per year. What does that mean? Take the annual nominal. Okay, so they're saying R over N. All right, this is how much the nominal rate, that's how much they're charging interest in one period of time. So if it's monthly, it's your annual rate divided by 12. So the annual nominal rate. Interest rates are generally quoted as annual nominal rate. It still sounds like the annual rate to me. The rate per compounding period. So this is misleading vocabulary here. Annual nominal rate sounds to me like the annual rate, right? But what it really is the rate per compounding period. So if they're compounding your interest, say 10 times a year at 10%, they would say the annual nominal rate is 1%. And you might think, oh, 1%, annual nominal rate, 1%. That sounds great. But if they're compounding 10 times a year, that means they're actually charging you 10% a year. Okay, so their vocabulary here, typical business vocabulary. Anything to try to rip you off, right here. No misleading words. Doesn't that sound like the annual interest rate? It's annual rate. I mean, what does nominal mean anyways? How many times have you used that in a sentence in your life? Right? Sure. It's like my dad trying to deal with Medicare or Medicaid. What is it for old people? Yeah, you get this like pamphlet that's like 600 pages, and it's like, you know, you're on the verge of like dementia, and you're trying to just, all you want to do is go to the doctor, and it's like, here's a 600-page book so you can understand, you know. It should be against the law, straight up, you know. But what they really mean here is the rate per compounding period. So if your annual interest rate is 10% and you're compounding 10 times a year, then that means that this would be 1%. And it would make you think, oh, I get an annual rate of 1%. No, it's 10% because they're compounding 10 times a year. Banks. I do, I despise them. So here's their little spiel about what I just did for you. Here you go. It's the same thing. They call it P plus I, lowercase I for interest. All right, so your amount is principal plus interest. And then the next pay period, this is your old principal. So there's your principal and then your interest. So this thing just keeps going up and it's n times in a year. So if you keep doing it for t years, you end up with a t there. Okay. Yeah, my adrenaline's still rushing. Somebody tried to run into me when I was driving my daughter today. I was so mad. Is it like illegal, like to get out of your car and kill somebody if they desperately deserve it? Right? I mean, he almost killed me. We're in the school zone going like 30 miles an hour. He's right in front of me. I got my daughter in the back. We're singing the wheels on the bus, you know. And he pulls into the right lane and then he proceeds to U-turn just directly in front of me. I just slam on my brakes. Everything in the car went flying into the windshield. I mean, he was right in front of me. I'm right behind him. He changes lanes to the right and then just hits his brakes and U-turns right in front of me. I was like inches away from T-boning this guy. I was so mad. Isn't there a law, like if you see red, you know, like if you do something in the heat of the moment, like you could totally get away with it? That guy totally deserved it. I say guy, it could have been anybody, I don't know. But they didn't wave or nothing. I was so mad. Right in the school zone, like during like school, like, you know, it's a good thing we're going 20 miles an hour. Huh? No, it wouldn't be. Not if somebody swerves in front of you. Like they were, but then they changed lanes. So they were in the lane to the right of me.
Oh, so they just were.
Yeah, they changed lanes and I was like, okay, great. And then he just hits his brake and pulls like right in front of me, like sideways. Yeah, that's a different, like if you rear end somebody, it's your fault. Yeah, you know, you shouldn't be driving that close to anybody. You stay off, you know, anybody, if they slam on their brakes as hard as they can, you should not run into them. So most people drive way too close. It's dangerous. And that's how you get all these car pileups, you know. It's like give people some room. All right, here. So here's our formula. They use the letter M here, but I think they change it to N. N. Why do they have M in here? Let's find out. T is the time in years. P is the principal invested. It may seem more natural to use formula 2, maybe seem more natural to use than 1, if R and T are given. On the other hand, if I, the interest rate per period, the formula, I don't know what the formula 1 was. It's not necessary to memorize both formulas. Use this one, but instead of M, call it N. All right. Where's their formula 1? Oh, yeah, formula 1 here, this is stupid. They use the lowercase I for interest, right? This is the one that you want to use, okay? Okay, here we go. Okay, there's solution. Again, the hardest part is typing these things into your calculator correctly and understanding the word problem. So if we have $1,000 invested, that's our principal, at 8%, R is 0.08. We want to find out how much, well, okay, what's the time though? Do they want it a year or 2 years? I guess we're just going to do it for 1 year. Oh, here we go. After 5 years, so T is 5. So A equals P times dang it, 1 plus R over N to the NT. That's our formula. So here, annually, N is 1. So we'd have our amount would be, there's our principal times 1, dang it, 1 plus R over 1 to the NT. N is 1, and we're doing this for 5 years. So if we plug this into our calculator, we have 1.08 to the 5th power times 1,000. Gives us $1,469.33. So that's not bad. 8% for 5 years, and we got like time and a half basically. B, semi-annually, that means twice a year. All right, semi-annually. So we have this exact same thing. Okay, but in here is 2. So I have 0.08 divide by 2, add 1, raise that to the 10th power, and then multiply by 1,000. And we get $1,480.24. So notice we made like an extra 11 bucks, right? Because we collected more interest on interest. All right, see here, we have the same thing, but quarterly means 4 times a year. So we have to do 4 and 4 times 5. So I got 0.08 divide by 4, add 1, raise that to the power of 20, and then multiply by 1,000, and we get $1,485.96. So we got an extra 5 bucks just by going from twice a year to 4 times a year. Now let's do monthly. So monthly, we take our rate, divide it by 12. We're going to do this 12 times a year times 5 years. So now I have 0.08 divide by 12, add 1, raise that to the 60th power, and then multiply by 1,000. We get $1,489.85. So we got an extra, what, 4 bucks maybe? By going from 4 times to 12 times a year. So it seems like we could just keep compounding interest more and more often and just keep getting more and more money, right? Yeah, it bottoms out eventually. Here's all their solutions. Continuous compound. Let's do the same example, but let's do part E. Continuous. Continuous. All right, if we do it like that, the amount would be PE to the RT. Our principal was 1,000 bucks. The interest rate was 8%, and the time was 5 years. So if we do that, we have 0.08 times 5. 0.08 times 5, e to the times 1,000, and we get $1,491.82. So it's not that different, right? You got an extra, what, $3? Okay, but that's the most you're going to get. You can't compound interest more often than constantly. Okay, so that's how this number E was discovered, was through finance, trying to figure out interest, which seems like, well, yeah, obviously that's where we would discover most of the mathematics came from commerce and trying to do, finance and dealing with business stuff, and it's where our numbers came from and all that. All right. Did that. Here's the compound interest. I already gave you this formula. All right, what will the amount in the account, what amount will an account have after 2 years? So there's our time. if this much is invested at this interest rate, compounded daily. Well, it's compounded daily. We have our principal, 1 plus our interest rate divided by 365. Because there's 365 days in a year. 365 times 2 years, right? Well, if I'm going to use my simple calculator, I need to know what this number is, right, ahead of time, which I should be able to do that in my head. 730, that's 730. So now I start off with 0.08, divide by 365, add 1. Hold on. 0.08 divided by 365, add 1. Raise it to the power of 730. Now multiply that by 5,000. And we have $5,867.45. We compound it continuously. We have the principal, e to the r t. So I got 0.08 times 2, e to the, and times 5,000, which gives us $5,867.55. So we made it an extra 10 cents, right? Not a lot, but I mean, going from daily to an infinite number of times, you might think it might be a huge difference. 365 versus infinity, right? But every time you compound even more, you're getting less out of it. So these are all super easy. The next level of difficulty is, instead of finding the amount, right? Because here's the formula, right? They just give you these numbers. You just figure out what the letters are, plug them in. All right, what happens if I know the amount, but I want to find out what the principal is? Well, you just have to solve for P, right? How would you do the basic algebra here? The principal would be the amount divided by this, right? So if I knew the amount, but I needed the principal, I'd do that, right? Easy. All right, well, what if I know the principal and I know the amount, but I want to know the interest rate? How do I get to the rate here? How would I get? Well, the first thing I could do is, if I'm trying to get the rate by itself on one side, I could divide by P. Oops. Divide both sides by P, right? Then I got to get, I'm trying to get to that guy. I'd have to get these out of here, right? Well, if you remember the log trick, you could do, pick any log. I'll pick natural log. Take natural log of both sides. Why would I do that? Because remember, a property of logs is if you have stuff to an exponent in there, that allows you to take this and put it over here, right? So let's see, and then I could divide by, let's see, I could divide both sides by this. I've still got this R in here, right? What do we do? We'll get to this later. You'll see that it's not too bad. All right. I can just see this clear. All right. It's hard. We got, this is just ugly, right? We'd have to do, let's see. I could do e to both sides. So I do e to all that, and then e to the natural log would go away, and then I would have this. Right? Then I could subtract 1 from both sides, and then multiply both sides by n. Multiply both sides by n. Right? So it's ugly, right? They won't ask you, they probably won't ask you to do this, all right? But it's a whole lot easier with the continuous compounding of interest. How do I solve for R here? I could divide both sides by P, take the natural log, and then divide by t. So that's a lot easier, right? The continuous one's a lot easier to deal with. So we will have examples like that here coming up soon. Use the compound interest. Right, these are just plug it in, plug in the numbers. What would the amount be? So here's your time, there's the principal, there's the rate. You just plug the numbers in. Y'all can do that. Let's look at, spend our time on the hard stuff here. So growth in time, let's see. Try to make sense of this word problem. How much should you invest? Here they're asking what the principal is. How much should you invest now to have a given amount at a future date? What annual rate of return have your investments earned? How long will it take your investment to double in value? The formulas for compound interest and continuous compound interest can answer these questions. Well, obviously. So how much should you invest now? So what should the principal be at 10% interest to have $8,000 in 5 years? All right. And we're going to compound quarterly. Okay, well, we know what A equals P times 1 plus R over N to the NT. So now we know these values here, though. Our amount here is 8,000 bucks. We want to know what the principal is. Our rate is 10%. We're compounding quarterly. So 4, and then it's 5 years. So it's hard. What I did up here is like algebraically figure out what R is, right? That's a real pain. But we can still do that. That's exactly what we're doing here. We're just going to simplify this stuff first, basically. But instead of R, we're going for P. P's not so bad. So P here is 8,000 divided by this. Is what it is. That's all it is, right? So what is this? This is 8,000 divided by, figure out what this number on the bottom is. So for something like this, I'm going to have to approximate an approximation, which sucks because I can't type this whole thing into my calculator, right? So I can do the bottom though. I could do 0.1 divide by 4, add 1, and then raise that to the 20th power. So I'm approximating the bottom, and I'm going to keep a whole lot of decimals here. Okay, because now I need to type into my calculator 8,000 and divide by that. So I'm approximating an approximation, which sucks. You don't want to do that. If you do it, keep a whole lot of decimals, because every time you're rounding something that's been rounded, you could end up way off. But we just need to be within the closest cent, right? Y'all all right over there? Y'all been talking constantly for like 15 minutes. All right. All right, here we go. I mean, it's important. Go take care of it, you know? All right, so now let's do compounded continuously. That was part A. So continuously, we have amount as principal e to the RT. So before I even plug in the numbers, principal is A over e to the RT, right? Also known as A e to the minus RT, but I don't want to deal with that. This is easier for me. Well, actually, this I can plug into my calculator in one step. This I can't. All right. With a simple calculator, you just can't do it. Not unless you know how to use these memory buttons, and I don't know how to use those. So our amount here is 8,000 bucks. Our rate is 10%, and our time is what, 5 years? So this I can do negative 0.1 and then multiply that by 5, so it's a negative 0.05, and then I can hit e to the, and then multiply that by 8,000. And we get $4,852.25. So it's pretty close to the same, right? 82, 52, $30 difference. All right, the less they compound it, the less it's gonna cost you. So the less you, wait, why do we have to have enter more here? They compound it less. Hold on. How much should you invest now? Okay, yeah, if they're compounding it less, you need more money, all right, to make more interest. All right, so if they're only compounding it quarterly, you're making less money, all right, than if they compounded interest continuously. You're getting less interest on interest on interest because you're basically investing and saving your money to buy a car later. All right, another example here. I'm just waiting for this stuff to get real hard. Like that simple interest stuff, those problems were really hard for a simple formula. Maybe they won't torture us because the equation is actually of decent complication here. How much should new parents invest? What's the principal? At 8% to have $80,000 as an amount toward their college tuition in 17 years. Compounded semi-annually, n is 2. All right, well, amount is p times 1 plus r over n to the nt. All right, if you want to just plug these numbers in, you can, but the principal is a divided by this. All right, or a the negative nt. All right, you do it like that. However you want to do it is fine. I might be able to do it like this in my simple calculator here. The amount here is 80,000, 1 plus, the R is 8% semi-annually, and then 17 years. I know this number here is 34, right? Oh, and I need a minus. The problem with this is I can do the 0.08, and then I can divide by 2, and then I can add 1. But then I hit the X to the Y button because I want to raise it to the negative 34th power. But when I hit the X to the Y, it's like, okay, to the power of, and I'm like negative 34. But when I hit negative 34, it doesn't say negative. It says, okay, subtract 34. So the to the power of button gets replaced with subtraction. You see what I mean? That's why you can't do this with your basic calculator. You need one where you can actually type everything out. The only way to do this is to do an approximation of an approximation, right? Yeah, I mean, it works. I mean, it's a hack and it works because you only need to be accurate to the cent, right? All the other decimals don't matter. So what we could do is leave it more like this, get rid of that minus and put that down here and say, okay, this is an approximation. I'm going to figure out what the bottom is. So I do 0.08 divide by 2, add 1 to the power of 34. And this is right, 3.794316 and so on. So now I can type in 80,000 and divide by 3.794316. And I get $21,084.17. All right, so that's how much we need to invest. We want to end up with $80,000. We're basically quadrupling our money, but it takes 17 years to do it at 8% interest. If we do this compounded continuously, how much do we need to invest? A equals P e to the RT. So P is A e to the minus RT. Because I have an e to the X button, I can actually do this with a simple calculator. I got 80,000 e to the minus 0.08 times 17. So because I can actually hit negative 0.08 and multiply that by 17, so I'm looking at a negative 1.36, and I can just hit e to the X boop, and then multiply by 80,000. We get $20,000, $20,532.86. So if you're compounding continuously, you're collecting more interest on interest, so it requires less of an initial investment. All right, 500 bucks less anyways. The difference between compounding twice a year versus compounding continuously, right? We're getting a lot more interest out of the continuous. We have to invest less at the beginning. One of these graphing yes, we all know they're useful, graphing calculators, but they're not as good as a computer, right? Why don't they say smartphones are great for, or an iPad? It's like graphing calculators should be outlawed. The only reason they exist is so they could sell them at like super high cost to students that already have laptops and smartphones. When I was in school, they're like $180, $250 and stuff. All right. Computing growth rate. Figure 3 shows that a $10,000 investment in a growth-oriented mutual fund over a 10-year period would have grown to $126,000. Well, that's not bad. You're getting 12 times the amount in the return, right? 10,000 to 126 over 10-year period. What annual nominal rate would produce the same growth if the interest was compounded annually or compounded continuously? All right, so this one is going to be fun. So we have a $10,000 investment over 10 years, and it has grown to this amount. So what is the annual nominal rate? So remember, the annual nominal rate isn't the annual interest rate, right? That is your rate divided by n. That's what we need to solve for. Remember that vocabulary I pointed out that was like totally misleading? I'm glad I emphasized it so much. I knew they were going to bring it up and try to like mess with our minds. So we need to find what R over N is, okay? Would produce the same growth if interest was compounded annually. That means N is 1. Compounded annually, that means R over N, is just R, right? The annual nominal rate is the same thing as the annual interest rate if you're only compounding once a year, okay? So for part A, we have A equals P times 1 plus R over N to the NT. But here, N is just 1, right? N is just 1, this thing simplifies to that. We are trying to find now what R over N is. Well, R over N is just R, so what is R? To solve for R, we plug in our numbers here, right? Or we could solve it before we even plug the numbers in. If I'm trying to solve for R, let's see, I could divide both sides by P, and then I would have this, right? Now I got to get rid of this exponent. So what I could do is pick your favorite log. If I do natural log of both sides, I get that. Natural log, any log, says with an exponent, I can bring this out front. Boom. All right, and then I don't need all these extra parentheses here. Yeah. All right, so now the T is out front. So let's see, how can I get to this? The divide by T, so I have 1 over T natural log of A over P would equal natural log of 1 plus R. So now to get to the R, I got to get out of the natural log. We could do E to the both sides. So this goes away. And then subtract 1 from both sides. So that's what R is. Let's see if we can plug in numbers. If this is one of the ones that's easier to do by plugging in numbers first, right? Let's try that instead. So what were our values here? I forgot. We have P is 10,000. The amount is 126,000. We're trying to find R. Oh, and T is 10 years. Let's plug our numbers in here. We have 126,000 equals 10,000 times 1 plus R to the 10. So let's do this. Boom, we can immediately do that. So that would give us boop, boop, boop. All right, so 126 divided by 10 is what? 12.6. Okay, so now we're still trying to get to the R. We could do, since this is to the 10, we could do log base 10 of both sides, because there's a log base 10 button. If we did log base 10, we would have log base 10 of 12.6 would equal 1 plus R. Because log base 10, no, that's not right. No, this is, I don't want to, that sucks. We don't want log base 10. That would help if it was 10 to the something. But this isn't 10 to the something, right? This was misleading. Do our natural log. I like it better. Natural log of 1 plus R. And since the 10 being in here, we can put it out front. All right, that rule, log base, this rule, R, natural log of X. You could just take that and put it out. Okay, so we could divide both sides by 10. And now we have to do E to the both sides. And then we could subtract 1 from both sides. That's what our R is going to be. I don't see any easier way to do that. Let's see what they do here. They do, oh, they use the 10th root button on your calculator. I've never seen a 10th root button before. But yeah, you could do that too instead of using the logs. I mean, algebraically, I'm trying to keep in mind we're trying to plug this into a calculator, but at this point, I could just do raise both sides to the 1/10th power, right? Take the 10th root. But I've never seen a calculator with a 10th root button. So I'm sticking with my natural log method. Because I mean, this is ugly, but it's not that bad. I could figure out what this number is, and then I can hit E2 there, and then I could subtract 1, right? It's not that bad, but let's see what else they do here. Seriously? And if you plug this into your calculator, you get this number because that's the answer. All right. But this you can actually plug in. I can't believe they pull a 10th root. I've never seen that before. I don't know. I mean, a 10th root, if you have like, I mean, if you could think of the number you multiply by itself 10 times to get that, like what number do you multiply by itself 10 times to get 1 plus R? Or 12.6. What number do you multiply by itself 10 times to get 12.6? I did, you know. Maybe there is a button like that. Let me look and see. I see a square root, a cube root. There is a Y, there's that button right there. I've never seen it before. They have a Y and then root X. So yeah, they do have it on your iPhone. Have to be careful as to what you're entering in first though. So yeah, we could do it that way. Yeah, so whichever way you like. That button does exist. Boom. I've just never noticed it before. It never occurred to me to take the 10th root of a number I was actually gonna take the 10th root of, you know? All right, so yeah, you could just do that. Divide by 10,000 and take the 10th root. Let me see if I could type it in correctly. 12.6 and x, y, and then 10, then subtract 1. Yeah, that's easy. We could do that. So yeah, this is doable. We could just totally do that. My way works well too, but you know, this you have a button and you can just do that in one step. So that's cool. All right. I learned something new today. All right, so what was part B? What if it's compounded continuously? All right, so let's see, part B here. It's compounded continuously. Here's our numbers. We have to be careful. Trying to figure out what this would mean. What would the annual nominal rate be if it's compounded continuously? Because that's, remember, this was R divided by N. It's the amount of interest you're charging every period. But if there's an infinite number of them, then you're not getting any interest. I don't know, maybe I misunderstood what they mean by this annual nominal rate. I don't understand how it's different than the annual interest rate. They didn't explain it very well in their paragraph or their one sentence. So we might have to Google that next time because I'm sure they're going to have more word problems because it was the only new vocabulary word introduced where you really have to understand it inside and out. But if we're doing this, if we're going to find our R here, okay, well, divide both sides by P. Take the natural log of both sides. And then divide both sides by T. So R is 1 over T, natural log of A over P. You're going to do this a whole lot. So we have 1/10 natural log of 126,000 over 10,000. So this is 1/10 natural log of 12.6. So let's see, 12.6 natural log divided by 10. We're getting 0.2533 or 25.33% compared to 28%. All right. Yeah, next time we'll explore whatever this means. All right. Maybe I misunderstood at the beginning of class, but it seemed pretty clear. Let's look at it again real quick before we go. Because if you're compounding continuously, to me, I thought it was the interest charged per interest period, right? So if you're compounding monthly, you take your annual rate and divide it by 12, right? But what does that mean if it's compounded continuously? Then you have an infinite number of like pay periods. I mean, I understand just find the interest, R. If they'd have given us one instead of compounded annually, where N was 1, and compounded infinitely number of times, if they'd have given us one that was anywhere between the two, we'd be able to figure out what the definition actually meant. All right, those are the two because of symmetry here. Where is this thing? Compound interest. Where'd it go? Blah, 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 blah. Here it is. 0.08 divided by 4 is 0.02 is the interest rate per quarter. Since interest rates are generally quoted as annual nominal rates, the rate per compounding period is found by dividing the annual nominal rate by the number of compounding periods per year. So, well, no, see, I mistook it. Wait, okay. I thought it said the annual nominal rate, comma, the rate per compounding period. I thought they were defining annual nominal rate by the phrase rate per compounding period. But no, they're talking about annual nominal rate, and then they're defining the rate per compounding period as the annual nominal rate divided by the number of compounding periods per year. So this does mean this is just your annual rate. All that is R. All right. This, the rate per compounding period, is your annual rate divided by the number of periods. So their placement of their comma is very unfortunately, you know. I thought they were defining this with this, but they're not. Like the comma basically ends a sentence, and then they are, I don't know, fucking flashcard. Then they're defining what a rate per compounding period is. We don't need a definition for rate per compounding period. It defines itself. It's the interest rate per compounding period, right? So annual nominal rate, that's just R. That's all it is. Why didn't they call it that in the first place when they had R? It's annual interest rate. Okay. So let's have a quick exam and get the hell out of here. Tenth root, man. We might be able to finish this up by the next class. Wish I could turn the pages faster. Now we're getting to APYs, whatever APYs are. Annual percentage yield. All right, we'll do that next time. Take some 12th roots. It's going to take an entire another class to do this. There we go. 3.2. I want to give y'all problems that are too hard. We'll do this one for our number 1. So this is our exam. Daily exam number 18. Here's your number 1. Pick out a good number 2 here. The problem up there in the 80s or something. There we go. Number 56. How long will it take? We didn't cover that, but you can do it. You have to solve for R. I mean, not R, T. If you could solve for R, you could solve for T. Right? T's up there in the exponent, though. So how do you do that? The way I did it, take the natural log, right? And then the T comes out. If you have to, that's if it's, yeah, you can do it compounded quarterly too. That's it for today, folks. Yeah.